This circuit is driven by these two 595 ICs, which are otherwise known as shift registers. These ICs work such that each time a rising edge occurs on the square wave which is inputted through the clock pin, one bit from the binary number which is inputted on the data pin enters the IC's memory. Each IC has 8 outputs, but since we need at least 14 outputs for this project, these ICs are daisy chained together by tying one 595's data out pin to the other 595's data in pin. Once all of the bits are inputted into the 595's memory, the latch pin, which has been held low this whole time, is held high so as to output all of the bits in the 595's memory. This mini circuit is used to toggle between the two ground pins of the dual display by using one NPN transistor and one PNP transistor. This is possible since when a high is presented on the 10,000 ohm resistor, only the PNP has a path to ground, and when a low is presented on the 10,000 ohm resistor, only the NPN has a path to ground. This array, called the lookup table, contains binary numbers which correspond with each letter of the alphabet, as well as a space and a question mark. Each bit in each binary number correlates with one segment of the 14-segment display. The order of how these bits correlate with different segments is presented above the table. This setup section simply initializes a few things. This loop section waits for something to be entered into the serial, reads what was entered, prints what was entered, and then sorts through every possible input so as to attach it to its corresponding part of the lookup table with these two switch statements. Finally, until the next characters are entered into the serial, the code applies a square wave to the mini circuit, which toggles between the two grounds, switches the binary inputs in synchronization with this square wave, and shifts out the binary input and outputs the binary input.